So this QR code is for people who want to register to try the first interchain EVM bridge, so interchain transactions through the EVMs, through smart contracts that you can write in Solidity. And this is how you can get tokens. I have 3 chains, you'll get tokens for all 3 chains to be able to send transactions between these chains. So this is done with Ethermint Evmos technology, Enbridge, and some other tools that I've coded, like a Web3 wallet for sharing your work. I am a volunteer. I'm actually sent here by the Evmos community by vote, which is something that I've never seen in other communities. So you can do work for a chain, and then the community, if they consider your work important for that chain, they can reward you by sending you to hackathons. You can see my work on Ethereum, EVM, Evmos on my YouTube channel. There are a lot of demos. And I programmed as a volunteer the following Evmos modules and features: the fee rewards module that will be live pretty soon, the global minimum gas price for both Cosmos and EVM, which is live now and has helped Evmos get rid of a lot of spam transactions, and proposals for cron transactions, eventual transactions, Evm Interpreter. So this is an Evm Interpreter inside the EVM. It's an abstraction that can help layer 2 solutions come in and have native tools that make them much precise and faster. And many other proposals. You can check them out at this site. So I am working under a volunteer project, which is the Laurel project. You can follow it on Twitter, and you'll see all of our work. The Evm Interchain. So this is a set of sovereign chains that implement Enbridge. So by Enbridge, you replay EVM transactions from one chain to another. And in the next minutes, you'll learn how you can interface with Enbridge from Solidity. Enbridge is a ring of blockchains. I already said that each transaction is replayed on a specific set of chains, and you can set that set of chains to whatever you want. The sender is an account abstraction that keeps its nonce synchronized. Because we're talking about replay, we need to keep our nonces synchronized. And all participating contracts get the same address on each chain. So that's how you do the replay. You get a unique instance of a contract. It's like a singleton that's actually represented on each chain with the same contract address. And I will show you a demo of the simplest state synchronization and more. But let me tell you about the dev setup. So we have 3 chains, as I said, based on Evmos Ethermint, Mythos, Logos, and Ethos. They are all using the same software. And you have IBC channels between each of them and one Enbridge. The Enbridge is based on a set of precompiles, and we'll look a bit at these precompiles. There are 4 of them: abstract accounts precompile, intertransaction precompile, which handles the interchain things, Cosmos SDK precompile, which actually allows you to send Cosmos messages through the EVM. And it's part of our, what we call, Quasar system of bridging the EVM and Cosmos APIs. And the Evm Interpreter precompile. The intertransaction precompile has 3 main functions that are quite important. You have emit transaction, which allows you to do an IBC transfer from the EVM. You have emit dependent transaction, which allows you to do a transaction on your current chain and one on another chain, but they should be dependent on one another, so if one fails, the other one fails too. Also through IBC. And then you have emit transaction multi, which allows you to send from one chain transactions at the same time on many other chains that you have a routing of IBC connections between them. So I've put all of these these precompiles and functions of the precompile under a single wrap, so it's actually easier. These are the precompiled address. So for people who don't know, precompiles act like a normal smart contract. So you have an address for them, but they don't have actual bytecode, EVM bytecode, because they are implemented natively in the client. But they can act like a smart contract. So they have an address, and then you have all these functions. So it's easier if you want to develop with them. And also you have documentation explaining exactly what each of these precompiles do. The abstract accounts one gives you access to do the EVM part of the transactions, and the inter-transaction precompile is based on interchain accounts from IBC. Okay, so now I have some demos, and we'll do this live. We'll see how it goes. I have this is an IDE that I can put, that I can make available for hackers who want to use Evmos and want to use, maybe even do something interchain with the EVM. It's an IDE where you can write with a Lisp-like language, and for example, it's very easy to set up. So we have this transaction. It's very easy to set up a transaction. It's like this. You have this function React contract. You put the name of the contract because you load the APIs. You put the name of the function, and you get immediately a UI, and you can test right away. So you don't need to set up and do a front end for your smart contract. In 2 minutes, you have a UI that you can test. So this is kind of the interface for the N-bridge thing. So what we'll do now, let me see if I am on the right account. I should be on the Mythos chain. Okay. I'm on the Mythos chain, account 4. So what we'll do now, I have selected Mythos, Logos, and Ethos. So we should be able to deploy a contract from Mythos to all of these chains. And I have Remix here. I'm compiling it. I'll be copying the bytecode and then the ABI and deploy it, and let's see if the live demo works. We need to wait a little bit because this is IBC channels and transactions. Okay, so the contract was deployed, but we need to get the deployed contract address. And this is a bit tricky. Because the address is derived from the abstract account corresponding to the Ethereum account that I've just used. But it should be at this address. So let's see if this works. So the contract should be initialized with a value of 5. Not this one. Bear with me a little bit. Okay, so finally, so it was I was one off with the nonce. So we have a contract deployed on Mythos. And now we can switch on the Logos chain and we should be able to get the same value, but let's test this in Remix to have another verifier than my own. So let's, okay, we change to Logos. We get the address. And the value is 5. So now we change to Ethos. The value is still 5. So let's do also a change of state. And we do this, we have the address set. We do this also multi-chain. So we should send this state change across all chains. We'll have a gas limit of something 1 million to be sure. Now we need to send the call data for the transaction that will be replayed on all chains. And I've made this easy with this tool that encodes and then automatically sets the call data. So we'll change the value to 8 on all chains. And now we need to be on the Mythos chain because this is the controller, and we will replay and we'll probably need to wait a little bit and the value should change. Okay, finally. So it's changed to 8. And again, we can, so here we are on the Logos chain. The value here has changed to 8. And on Ethos, it's also 8. So this is a multi-chain transaction triggered by the EVM. What we can also do is dependent transactions. And let's do this using an ERC20 contract that I already deployed. So it's an Interchain ERC20 contract, and we'll talk about it in a minute, which has this address. And we need to get the ABI. Okay. So for this, we are on the Mythos chain. We can move tokens from one chain to another chain from our account on, again, our account, or we can transfer from our account on one chain on somebody else's account on another chain. The total supply remains synced across chains. And let's see what balance we have now. on this account. And this is a hex number. Let's so it's 9999 something with an 80 ending in 80. So we are going to move from 7001 is the chain ID for Mythos to 7002, the chain ID for Logos. And we'll move from this address and the value will be 10. But let's look, so I have this loaded here. Let's look on Logos and see our balance. Okay, balance for this account is this very nice number with a lot of zeros. So we go back here and we need to encode this transaction. It's a move transaction. We press here and we have the call data that we should use. Let's do this again. 7001, 7002 from our address, and we will move 10 tokens. And for some reason, the encoding doesn't work. So let's go over this. You've seen, at least you've seen a multi-chain transaction. So a normal EVM transaction, you have the function signature, you have the input, this is the call data, and then you send the contract address. For the interchain transaction, especially multi-chain transaction, you have the set of chain IDs where these transactions will be replayed. You have the contract address, which is unique across chains. You have the function signature and your input. Other tech that that goes along with this, and you'll see this in the YouTube videos, in the demos: gas refill precompile, dtype DB, singularity governance, because now you can do governance from one chain on other chains. And I think this is quite interesting, and no one has done this before. I've shown you Mark's factory already, and this is how you can, when you set the ABI, this is how you can, but let's actually try this. So this is a new Mark's factory IDE. You put the contract name, You put the contract address and then the ABI. You just load it in the page. Let's just write it down here. And you get the function from the ABI. So this is how fast you can have an interface for your contracts. And then this is, I'll show you this to people who will want to hack on Evmos. This is an Interchange Wallet, and if you do your front end with Mark's Factory, you will be able to just share your work by mobile. And this is related to the Evm Interpreter, which allows you to do all sorts of interesting things in low-level EVM. And I am going to show you a little bit of how this works. You can actually use a spreadsheet for it and write down EVM assembly instructions in a spreadsheet, like all sorts of push, add, and then create bytecode in a spreadsheet. And then you have this bytecode and you have the Evm interpreter precompiled, so you can interpret this bytecode and get information like how many reads or writes are in that bytecode and what you have on the stack at a certain location in the bytecode. And nice things like this for hackers. Okay. If you want to know more, just if you see me around here and you've got your tokens, we can go through these steps together and register, get tokens, create interchain accounts, create abstract accounts for EVM interchain transactions, forward the abstract accounts on the other chains, deploy on multiple chains at once, and then simple, dependent, and multi-chain transactions. And that's it. I'm right on time.